Hello everyone, I'm Anurag Jain. I'm an AI and LLM developer. Welcome to a brand new video series focused on MCP, the Model Context Protocol. This series is not theoretical. The goal is to explain MCP using real life practical examples. We won't just talk about MCP, we will build MCP servers, deploy them, and use them to solve real day to day problems. In this introductory video, I will cover what MCP actually is, what it is not, how MCP is typically deployed in real systems, how it works with popular LLM and automation tools. Specifically, you will see how MCP integrates with tools like Claude, N8 and Langflow. By end of this series, you should be able to understand MCP conceptually, build your own MCP servers, plug them into your existing LLM or automation workflows, and use MCP in a way that's actually useful in everyday work. Let's start by understanding what MCP really is and why it exists. Before we dive in, here is a quick look at what we will cover in this video. First, we will start with LLMs without MCP. This is how most people are using LLMs today. I will show the limitations, pain points, and why things start getting messy as soon as you want real integrations or real world actions. Next, we will cover MCP in a nutshell. This is a high level explanation, not deep protocol details. You will understand what MCP is, why it exists, and the core idea behind it in just a few minutes. Then we will move to LLM with MCP. This is where things get interesting. I will show how MCP changes the way LLMs interact with tools, services, and systems. You will clearly see the before and after difference. After that, we will talk about practical usages of MCP, not theory, no hype, real examples you can use in day to day work. Finally, we will wrap up with takeaways and what's next, key points you should remember from this video, and a preview of what we will build and explore in the upcoming videos in this series. The goal is that by end of this video, you will not only understand what MCP is, but also why you might actually want to use it. So let's start with how things look before MCP. So LLMs are incredibly good at reasoning and language, but the moment we ask them to do something in the real world, for example, create a ticket, fetch data, trigger workflows, things start to break. In this video, I want to explain why that happens and where MCP actually fits. At its core, an LLM does one thing. It predicts the next token. So basically, it's a text in and text out. Out of the box, an LLM cannot call APIs, trigger workflows, read databases, or take actions. So by default, LLMs are reasoning engines and not action engines. Everything we see today, agents, tools, automations, that is a layer on top of this. Most systems today solve this by hardwiring tools into the model. We declare tools in advance, define the schemas, and hope the model calls the right one. To be honest, this works fine for demos. It might even work fine for 3 to 5 tools, but then this approach doesn't really scale. As the systems grow, tools become tightly coupled to the prompts, tightly coupled to the frameworks, hard to version, hard to swap. Every agent framework, be it N8N, Langflow, or any other, ends up re-implementing the same idea in slightly different ways. This would result in different code bases for every implementation, while the basic functionality of the MCP tool remains as is. This is the problem MCP is actually trying to solve. So MCP, which is Model Context Protocol, it's not an agent framework. MCP does not make models smarter. It makes tools interoperable. It defines a standard way for the models to discover what kind of tools exist, understand how to call them, and receive structured results. So as an as a comparison, REST protocol didn't make the server smarter. It made clients and servers work together. MCP plays a similar role for AI tools. With MCP, the model doesn't need to know all the tools in advance. It can ask what tools are available, how do I call this? Tools can be added, removed, or updated without retraining the model or rewriting the prompts. Important thing here is MCP doesn't remove complexity, it just moves it to the right layer. Now I'm going to show you the usage of an MCP tool, which is a weather application that I created to get the weather information for a given city using some popular AI tools which are N8N, Langflow, and Cloud Desktop. So this is my N8N workflow. I have created an AI agent. So if you are not aware of N8N, I will create a separate video series explaining what N8N is and how it can automate the LLM workflows. But for just for the sake of this video, I am assuming with N8N knowledge that when you put an AI agent, you can add your AI chat model as well as the MCP client. So that's where I have added my own MCP server, which responds to the queries which are related to the weather information. And the tools are available as per the definition in the MCP server. So the two tools which are there are get weather and weather summary. As you can see, the tools have been discovered by N8N itself. So to test this out, I'm going to send out a query that use the available tools to get a 3-day forecast for Montreal. So when I send this request, the request will be first processed by the LLM model itself for natural language processing, which then invokes the MCP client, and MCP client, which is interacting with the weather system using API, will return me the desired output. The same thing has been added in Langflow, which is another popular tool. And if I go ahead and request the similar thing in Langflow, and again, my MCP tool is connected over there. So it will follow the very same workflow as we saw in N8N. It will first go to the LLM, which I have, which I am using, which is OpenAI GPT, and then invoke the MCP tool, which is working in the backend to pull that information. And similarly, I have done the integration with Claude. So in the next video, I'm going to cover the implementation of our first MCP server in Python and deploy the same so that the tool can be used in the AI tools we just saw. We will then move to more advanced use cases where we will leverage physical AI devices such as OAK-D camera. Till then, take care and thanks for watching this video till end. Feel free to like the video and subscribe to the channel in case you like the content. Thank you.